So today we're going to start with ellipses. We're going to write and graph them. The definition of an ellipse is the set of all points whose distances from two fixed points have a constant sum. Those two fixed points are called foci. Each one is a focus. And the line through the foci is called the focal axis. It's also called the major axis. So oftentimes you'll see this called the major axis. And then the axis that goes through the center here is called the minor axis. The points where the ellipse touches either the major axis or the minor axis are called vertices if it's on the major axis. So there's a vertex here and a vertex here, or co-vertices. This is a co-vertex if they're on the minor axis. You can also have an ellipse that is longer going up and down, and the only thing that changes is the equation of the ellipse. There are three values that you keep track of in ellipses. C is the distance from the center to the focus. B is the distance from the center to the co-vertex. And A is the value of the center to the vertex. So A is always larger than C in ellipses. And we'll get all of these values out of the equation for an ellipse. So now you can see that there are ellipses that can be centered at HK. And so if here's your center and here's your center, we still have the same relationship where the distance from the center to the focus is C, and so the point would be H plus C. The distance from the center to the vertex is A. And then the distance from the center to the co-vertices, which are not marked on this particular picture, is B. So then when you look at the equations of the ellipses, whether they run left and right or up and down, you can see that we have an A value and a B value in each of the equations. The difference in the two equations is that if it goes left to right, A is under the x squared. So this is kind of left and right. It's longer left and right. And if it goes up and down, like this example here, then the A value is under the y. And that's how you really tell which direction your ellipse is going. Often in the problems, we are asked to find the foci. So we need to find the C value, and you can see that here. The foci are H plus or minus C or K plus or minus C. And the relationship is down here, but I think it's actually easier to think about it as C squared equals A squared minus B squared. So A is the distance from the center to the vertex. It's always going to be the largest, so then we have to subtract off the distance to the co-vertex, or to the, on the minor axis, to the co-vertices to get our foci. And then oftentimes conic sections talk about eccentricity, so that threw that in here. We are not going to focus on it that much, so I'll come back to it if we need it. All right, so now we're going to draw an ellipse with A equals 5, B equals 4, and C equals 3, and the foci are on the x-axis. And then we want to give the coordinates of the foci and the vertices. So if the foci are on the x-axis, then that means that the x-axis is our major axis. So this ellipse is essentially running left and right. So we'll go ahead and draw on our axes. And I made these grids smaller so that it would be easier to put the conic sections or the ellipses on the graphs without going off the grid. All right, so we're centered at the origin, and we know that A equals 5, so that's where our vertices will be on the x-axis. So we can go ahead and write that our vertices will be at 5, 0, and negative 5, 0. The B value of 4 means that our covertices, which we're not asked to list, but we can still draw in to help us graph it, will be 4 up and 4 down from the center or the origin. And then our foci are 3 units from the center. So I can mark them with little x's. We can give their coordinates as negative 3, 0, and 3, 0. And then we need to connect this. It basically looks like a football, so try and make it not so lumpy. And we've now drawn our first ellipse. In the second example, we want to draw an ellipse with a minor axis having a length of 6. So if the minor axis is 6, that means that 2b equals 6, so b equals 3. And a major axis with endpoints 0, 9, and 0, negative 9. So that tells us that our major axis has a length of 9. So that means that A equals 9. And then we want to give the coordinates of the foci. So first we'll graph it by first drawing in our axes. Since the endpoints are 0, 9, and 0, negative 9, we know we're centered at the origin, and we'll go up 9 and down 9. And then we can mark in our minor axis having a length of 6, aka 3 to each side of the center. And then we can go ahead and draw this in. Again, we want to avoid having this be pointy, so make sure that you're curving at the vertices and at the covertices. Now the problem asks us to find our foci. So to find our foci, we need our c value. So we know that c squared is equal to a squared minus b squared. So c squared is equal to 81 minus 9. So c squared is 72, which means that c is plus or minus root 72, which is plus or minus 6 root 2. The foci will be on the major axis, so they'll be somewhere on this y-axis. So then when we write the coordinates, we need to write them as 0, comma, 6 root 2, and 0, comma, negative 6 root 2. And those are our foci. All right, 2 more equations, 2 more examples, so let me move us down so we can see them better. The first one is in standard form, and we know that because it's equal to 1. So we can go ahead and write our center. Since there are no h or k values, this is 0, 0. Then to determine what's a and what's b, we look at the numbers in the denominators, and we literally look to see that which one's larger. So 64 is larger than 36. That means that a squared is 64, a is 8, b squared is 36, so b is 6. And since a is under the x value, we know that we're going to run along the x-axis. So we'll go ahead and draw our x-axis in. Since our a value is 8 and it's under the x squared, we'll go ahead and count 8 to the right and 8 to the left. And then since our b value is 6, we can count up and down 6 on the y-axis. So now we know that our vertices are 8, 0, and negative 8, 0. Our co-vertices, which we weren't necessarily asked for, are 0, 6 and 0, negative 6. We'll go ahead and graph it. And to find our foci, we'll use that same relationship, that c squared is equal to a squared minus b squared. So c squared is going to be 64 minus 36, which gives us a c squared value of 28 and a c value of plus or minus 2 root 7. So then our foci are on the x-axis. So they'll be at 2 root 7 comma 0 and negative 2 root 7 comma 0. In example 4, this is not in standard form because we're not set equal to 1. So we're literally going to divide every term by 36. And that'll give us x squared over 36 plus y squared over 9 equals 1. We'll again be centered at 0, 0. And again, running along the x-axis because 36 is larger than 9. We also know from our equation now that a equals 6 and b equals 3. And then we can go ahead and graph this. Draw on our axes. And we'll count 6 to the left and the right of the origin. So our vertices are at 6, 0 and negative 6, 0. We'll count up and down 3 on the y-axis for our co-vertices. We'll go ahead and draw this in, and again we want to make sure that it's round and not too pointy. I got a little pointy there. And then we need to find our foci. So we'll go ahead and say c squared equals a squared minus b squared. So c squared is 36 minus 9, which is 27. So c is plus or minus 3 root 3. Since our foci are going to be on the x-axis again, we have 3 root 3 comma 0 and negative 3 root 3 comma 0. Okay, in this example, we're not centered at the origin. Instead, we're centered at 1 comma negative 2. And we can look at the two values and see that the 9 is obviously larger, so that means that our ellipse is going to run up and down. The a value is going to be 3, and the b value is going to be 2. So we'll go ahead and graph this by first drawing in our x and y axis, and then we'll mark our center 1, negative 2. From there, because our a value is 3 and it's under the y, we're going to count up 3 and down 3 for our vertices. So our vertices are at 1, 1 and 1, negative 5. We'll use the b value to find out how wide this thing is and count 2 to the left and 2 to the right of the center. And we'll graph it. And then we will use c squared equals a squared minus b squared to get that c equals plus or minus root 5. So that plus or minus root 5 is coming up or down from our vertex, or from our center, excuse me, not from our vertex, from our center. So the x values are not changing, but the y values are. So the way that we write this is that our foci are 1, comma, well, we start at negative 2 and we go up root 5, or we start at negative 2 and we go down root 5. So that's where our two foci are. in the last example with just an equation, we can see that we're not even close to being in standard form. So the first thing we need to do is regroup our x and y terms together. And move our constant to the other side. Now we're going to complete the square, but as I said yesterday, we need to make sure that our coefficients are 1 in front of the quadratic terms. So we're going to factor out a 9, and then we're going to factor out 25. So this will be x squared minus 4x, I'll leave a space, plus 25, and then y squared plus 2y equals 164. So to complete the square for the x terms, we would take negative 4 and divide it by 2 and square it, and we get 4. So we want to add 4 on the inside, but since there's a 9 as a coefficient to our parentheses, we're actually adding 36 to the whole equation, because 9 times 4 is 36. Then we'll do it again with the 2 and the y terms. We'll take 2 divided by 2 and square it, and we get 1. So inside the parentheses, we're adding 1. But with the 25 coefficient, 1 times 25 means that we're adding 25. So then we get, if we rewrite this, 9 times the quantity x minus 2 squared plus 25 times the quantity y plus 1 squared equals 225. This is closer to standard form, but we need to be set equal to 1. So we're going to divide everything by 225. When we do that, we get x minus 2 squared, 225 divided by 9 is 25, plus the quantity y plus 1 squared over 9 equals 1. So now we know that our center is at 2, negative 1. Since the 25 is under the x squared, this runs left and right. We get an a value of 5 and a b value of 3. So we can go ahead and draw this in. So we'll go ahead and draw in our center of 2, negative 1. And then since a is 5 and it was under the x squared term, we'll count 5 to the left and 5 to the right of that center. And that gives us vertices of negative 3, negative 1, and 7, negative 1. Then we will graph from our center with the b value for our minor axis, so we'll go up 3 and down 3, and we'll connect our points. And then the last thing we need are our foci. So we have c squared equals a squared minus b squared. So 25 minus 9, which is 16. So c equals plus or minus 4. So then our foci are plus or minus 4 from our center, moving along parallel to the x-axis. So that gives us foci at negative 2, negative 1, and 6, negative 1. All right, for our last example, we have a word problem. So it tells us that we have a semi-elliptical archway over a one-way road. And it has a height of 10 feet. And a width of 40 feet. So right away we know that our a value is equal to 20 and our b value is equal to 10 because we're centered along what would be the x-axis, and the whole distance from one side of the ellipse to the other is 40, so half of that is 20, and then halfway up is, or the distance along your minor arc is 10. All right, so now we've got a truck. I'll draw the truck in. Hopefully it'll drive down the center of the road. And the truck has a width of 10 feet and a height of 9 feet. We want to see if it's going to clear the opening of the archway. So we want to see if at this point right here, where essentially our x value would be 5, if our height for the opening, for the ellipse, is greater than 9. Because if it's greater than 9, then the truck can drive through. So we'll go ahead and write the equation of the ellipse. So x squared over 20 squared plus y squared over 10 squared is equal to 1. We'll clean that up. So we want to know at x equals 5, what does y equal? So we'll go ahead and plug in 5. We'll get 25 over 400 plus y squared over 100 equals 1. So y squared over 100 equals 375 over 400. So y squared equals 375 over 4. We'll use our calculator and we'll get that y equals approximately 9.68. So since 9.68 is greater than 9, the truck clears. Yay! All right, let me know if you have any questions.